Let's take a look at a different style of integration by parts question. I have the integral of e to the 2x times sine x. And we can start off by highlighting the first term here, which is e to the 2x, and we can go ahead and highlight the second term, which is sine x. After that, we can definitely approach this question basically the same way that we approached the other previous problems by setting up a derivative and an integral column here. Our derivative will start off with e to the 2x, and my integral column will start off with sine x. Okay, so when you start taking the derivative of e to the 2x, I get 2e to the 2x. And if I take the derivative again, I get 4e to the 2x. And if I take the derivative one more time, I get 8e to the 2x. Alright, so one thing that you might notice is that the derivative column actually never terminates. So this is definitely a different style of question where we need a few more techniques and tricks to kind of finish off the problem. So one question that you might wonder is, when do I stop on the derivative column? Well, it actually depends on your integral column, starting with sine x. The plan is you want to keep on taking the antiderivative until you see sine x appear again in the cycle. Okay, so what does that look like? Well, what's the antiderivative of sine x? It's going to be negative cos x. And then the antiderivative of negative cos x is going to be negative sine x. And this is where I can stop because I do see a sine x right here, and that matches with the original sine x to start off the problem. It actually doesn't matter if you have a minus sign in front. As long as you see sine x, then you can stop. Alright, with that, then you can get rid of this 8e to the 2x. You don't need that anymore, and this is your table setup for this particular problem. Now, what you can do next is you should definitely set up another column here for your plus and minus signs. So I have a plus, minus, and a plus. And I would start off, and then I would go ahead and highlight the first row. So plus e to the 2x, and that's going to multiply with negative cos x. And then I have negative 2e to the 2x, and that's going to multiply with negative sine x. So we can definitely continue to use that same technique. However, because this is a different kind of problem, there is one extra new step at the very end. We actually have to take a look at this last row as well, and we need to include that back into our steps here, and I'll do that a little bit later on. Let me go ahead and take care of the rows first. So I have, in my first row here, there's a positive and a negative, so that's going to be negative e to the 2x times cos x. And let me just erase that since I'm done with that row there. And then I have a negative and a negative, so that's going to be positive 2e to the 2x times sine x. And let me just get rid of this now. And the new step is that I need to take a look at this last row here, and I need to write that as an integral to kind of finish off the problem. So I have a positive and a negative, so that means a negative sign will win, and then I need to write this as an integral. So the integral of 4e to the 2x times sine x. And if I have an integral sign, I need to have a dx as well. So that's kind of one of the new steps to this particular problem. Since this derivative and this integral never terminates, when we get our repeating pattern, we just want to write that as an integral at the very end there. Okay, so what we're going to do now is we're going to tie this back to the original problem here. So the original question, if I circle it up here, and if I bring that down, is actually the integral of e to the 2x times sine x dx, and that's going to equal to all that. So this was the original problem, and then we have all of this, and you'll notice at the very end here I actually have another integral sign right here. And now the plan is I want to take this integral sign at the very end here, and I want to bring it over to the left hand side. Okay, so it's kind of like solving like an algebra equation now. If I have x over here and if I have 4x plus 6, it's kind of like I want to take this 4x and bring it to the other side, right? So similar idea here. Okay, so let's take a look at this negative sign and this 4. That's kind of like saying you have a negative 4. If I bring the negative 4 to the other side, it'll become positive 4. so positive 4. So that's going to be the integral of e to the 2x sine x dx plus 4, and then the integral sine of e to the 2x times sine x dx, and then that's going to equal to all of this right here, this green stuff right here, which I'll move over here. So that's going to be negative e to the 2x times cos x plus 2e to the 2x times sine x. Okay, and then there's actually like an invisible 1 over here. So let me highlight that in blue. There's invisible 1. So 1 plus 4, if I add those two coefficients, that's going to give me a 5. So 5 times the integral of e to the 2x times sine x dx, and that's going to equal to all of that. Let me just write that one more time. E to the 2x times cos x plus 2e to the 2x times sine x. And then the last thing I need to do here is I need to divide both sides here by this 5 here. So that means that this 5 and that 5 will cancel out. And then I can finish this off by putting a plus c over here, and that would be my final answer for that problem. So it's definitely a different style of a problem, and I would definitely go back and redo this problem again if you need to kind of get familiar with writing that last step as an integral. Remember, I think this was the step that was definitely new, and once we have this thing kind of set up, we can bring it to the other side of the equation and actually match it with the original problem, combining like terms and then dividing by that leading coefficient, which was 5 in this case. Okay, so let's do one more problem just like this, and after you see one more problem, you'll see that is just basically maybe 2 extra steps compared to all the previous problems that we've done so far.